Hello everyone, welcome back to Algebra. This is Mrs. Pinero. Today I'm going to teach you how to use the distributive property and then to combine any like terms to simplify expressions. So first let's review what the distributive property means. So the distributive property is when we multiply a number or a variable across a sum or a difference. Now, a sum and a difference can be the same thing. If you're subtracting, you could change that to add. So that's why they usually just say sum. So if you multiply across an addition or subtraction problem, that is what we're using for the distributive property. Sometimes you can use the distributive property to make things easier for you. For example, in your head, you might think this way. This is how I think. 4 times 23, what I do is I break that in my head to 20 and 3. It's still 23. And then I multiply 4 times 20 to get 80. And then I multiply 4 times 3 to get 12. Those are both easily multiplied in my head, and then I can easily combine those to get 92. That's using the distributive property in multiplying. Now, sometimes you're going to have a variable, and you can't do it any other way. So in order to simplify this expression, I would multiply 5 times the letter n. This variable, we don't know what it is, so we just put 5n. Remember, push them together. That means multiplication. Bring down the plus, and then 5 times 1 is 5. So that's a little review of the distributive property. Now, I want to explain about combining like terms. Like terms means they have the same variable, so n or x or y, and those variables have to be to the same power. So if it's squared, they have to both be squared to be alike. If it doesn't have a variable and it's just a number, they can all be combined. So look at example 3. Example 3, we have 3m. So what I'm looking for is another m and to the first power. So this number right here and this one here are the same. They're both m to the first power. I can combine 3 minus 2 to get 1m. Now let's look at the 5n. This 5n is an n to the first power. I see another n here, but this is to the second power. This is not the same. They are not like terms, so I cannot combine them. So I will just bring down the 5n separately from n squared. And then 9 being what we call a constant, it's not variable, it's constant. 9 is always 9. It just comes down the way it is. And that would be how we would combine these like terms in this expression. So now what we're going to do on these examples below is we're going to do the distributive property and combine. So I'm going to go 5 times w is 5w, and then I'm going to go 5 times 8 is 40. Bring down the 3w. I'm finished with distributing. Now I'm going to combine my like terms. These are both w to the first power. So those two can be put together into 8w plus 40. And that is simplified as much as we can. We cannot simplify it further because we don't know what w is. This is 40. It's a constant. It cannot be combined with this because this one is a variable and we don't know what it is. Now let's look at example 5. On example 5, the 10 has to be distributed to these. See, they're pushed together? There's an invisible multiplication symbol there. You cannot subtract first. Some people get confused and they subtract these and then distribute. But remember, on the order of operations, subtraction is the last step. So multiplying comes before that. So we're going to distribute because that's a form of multiplying. We're going to distribute 10 times z, that would give me 10 z's, minus 10 times 2 is 20. Bring down the minus 5. Now I can combine my like terms, which are these constants. They don't have a variable. They're both constants, so they can be combined. But 10z has to stay separate because it's a variable and we don't know what z is at this point. So when I put these two together, I get minus 25. And on example 6, this one's a little more complicated. Remember, we don't want to subtract first. We don't want to add first. We want to multiply first. So we need to do the distributive first. We're going to multiply 3 times g and 3 times 2 before we do anything else. But there's a little catch. We're not really going to multiply by 3 because this minus here is attached to the 3. What we need to do first is remember that this subtraction problem is really an addition problem. We are going to add the opposite. So that 3 isn't really a 3, it's a negative 3. So we have to distribute negative 3, not positive 3. Very important to remember that because that will mess up your constant here if you forget to change the sign. So I'm going to go, well, let's bring down our negative 11, bring down our plus sign, and now we're going to go negative 3 times g, and then we're going to put a minus sign, and we're going to go negative 3 times 2, which is negative 6, and then bring down our g. All right, so now all we have is adding and subtracting, so we're going to go left to right. We're going to go with the negative 3g has to be combined with positive g, because those are like terms, so that's going to be negative 2g. And then we have a negative 11, I'm going to rewrite it over here, minus negative 6. So all I did was use the commutative property to put the negative 11 with the negative 6. So we have a subtraction problem here. I'm going to change this to addition and change this to the opposite. I'm going to add the inverse. Keep, change, switch. Negative 11 plus positive 6 is negative 5. So you can leave it like that, but most of the time in your book, instead of having a plus and a negative, they'll change it back to subtraction. These are both correct, and they're the same thing. All right, if you have any questions, just let me know. Have a great day.